everybody. So we're going to talk about how to compare and organize irrational and rational numbers. So the first thing we're going to do in this first example, we're going to look at find the rational approximation of the square root of 15. The way we want to do this is we want to take things that we know. So if I'm taking the square root, I want to kind of place it between two perfect squares. So I have to think of what two perfect squares the number I'm given falls between. So in the case of square root of 15, I'm going to look at 15 and say, well, what two perfect squares does 15 fall between? The first one is 9. 9 is a perfect square. The other one is 16. Now the reason I know this is because I know my perfect squares. I know what my perfect squares are. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, etc., etc. It's a good thing to know the first 12. It's really good to try to get up to 15 or 16. Okay, so 9 is less than 15 is less than 16. What we're really looking for is the square root. So I'm going to say, okay, well, the square root of 9 is less than the square root of 15, which is less than the square root of 16. The square root of 9, remember, square root means what number times itself gives you this number. So what number times itself gives you 9? 3. Square root of 16. Well, what number times itself gives you 16? That's 4. Okay, because 4 times 4 gives you 16. I know some of you probably thought some other number, but it's 4, not the other number. Okay? So now I know that the square root of 15 falls somewhere between 3 and 4. But the next thing I kind of want to do is see, well, we want a rational approximation. So we want to kind of get it closer. We want to get a decimal to kind of be like, well, this is kind of where it's close to. So I look and I see that 15 is closer to 16. So, and it's really close. So I'm going to go, it's got to be maybe 3.9. Okay, so I'll do 3.9 times 3.9. And when I go to my calculator, I already did this, so I'll just for show. Alright, boop, boop, boop. 3.9 times 3.9 gives me 15.21. That's a little high. So I'm going to try 3.8. 3.8 times 3.8. I'll actually do it this time. Gives me 14.44. So I know that the rational approximation of square root of 15 is somewhere between 3.8 and 3.9. So I can always try to get a little closer, but I'm going to go right now. This is about where square root of 15 falls, somewhere between 3.8 and 3.9. So that's what we call a decimal approximation. We could say it's somewhere between 3.8 and 3.9. This next one we're going to compare negative 1.96312 ... It just keeps going, and negative the square root of 5. So we already kind of know this one. We know it's negative 1.96 and so on. One of the things we have to take into account is when we have negative numbers, it kind of flips things. the smaller the negative number, so like a negative 1, is going to be bigger than a negative 10 because it's closer to 0. It's closer to the positives. So really we want to see is negative the square root of 5, is it actually going to be something that goes more negative than negative 1.9, or is it going to be more positive, more towards 0, closer to 0? So I want to see, well, where does square root of 5 fall in between? Alright, so I'm saying negative square root of 5. So I'm going to do the same thing again. I'm going to say, okay, well, where does negative 5 fall between? Well, if I use my greater than symbols, less than actually, well, negative 5 is, actually I have to do, can't do negative. Alright, 5 is less than, 4 is a perfect square, so 4, and then square root, and then 9. 9's a perfect square. So now if I take these square roots, square root of 4 is 2. Square root of 9 is 3. So the positive square root of 5 is somewhere between 2 and 3. That's a negative. So I gotta flip that. So negative 3 is less than negative square root of 5 is less than negative 2. So when I look at that, I see, well, negative square root of 5 falls in between negative 2 and negative 3. Negative 1.96 is actually greater than negative 2. Alright, because remember, again, when we're negative, we have to think the opposite. Negative 1.9 is actually greater than negative 2, negative 3, and therefore negative square root of 5. So I can actually say negative 1.96312 dot 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 is greater than negative the square root of 5. Alright? Again, if the negatives weren't there, we could flip it around, but you gotta pay attention and always remember, the negative will change the way we think of the numbers. What normally we would think is bigger will actually wind up being smaller. Okay? So the next one we have here, I actually need to raise this up a little bit. Make sure I don't write on the wall. Okay. Wife wouldn't like that. Alright, so we have here, does 1 over 6, negative 3, square root of 7, negative 6 over 5, or 4.5 come first when the numbers are listed from least to greatest? And then it says explain. Well, sometimes explain can be, you have to write it out in words, and sometimes explain is just, here's my work, and it explains why I decided to do what I did. So I'm going to show some work. So first off, I'm going to change these things all to decimals. It's going to make things easier to compare. So 1 over 6, when I divide 1 by 6, I'm going to get a repeating decimal. I'm going to get 0.16 repeating. Just the 6 is repeating. So it's 0.1666666666666 and so on. Okay? Negative 3 is negative 3, so I'm just not even going to write it down. Actually, I will. I'll write it over here. Okay? Then we get to square root of 7. Again, where does it fall between? Well, 7, the two perfect squares it falls between, 4 is smaller, 4 is a perfect square, and 9 is bigger. Take the square roots. Square root of 4 7 yet. And then square root of 9 is 3. So I know that the square root of 7 is going to fall somewhere between 2 and 3. Make a little bit of room. Negative 6 over 5. We got another fraction. When we do this, well, 5 goes into 6 once, so that's a negative 1. And then it leaves a 1/5, so then 5 into 1 is a 0.2. So that's negative 1.2. And then the last one is 4.5. So first off, which of these is the least? 0.16 repeating is small. Negative 3 is smaller. Okay. Negative 3 is smaller. Square root of 7 falls between positive 2 and positive 3, so it's going to be bigger than negative 3. Negative 1.2 compared to negative 3. Your initial thought might be, well, negative 1.2 is smaller, but again, remember, with that negative, it's talking about the distance from 0. So is 1.2 farther from 0, or is 3 farther from 0? 3 is farther from 0, so that's the smaller of those two negative numbers. And 4.5 is positive. So negative 3 is actually the smallest of these numbers, followed by negative 6 over 5, then 1 over 6, then square root of 7, since it falls between 2 and 3, and lastly 4.5. So negative 3 is actually the smallest. Okay. If you're still having trouble figuring out comparing negatives and positives, definitely look up stuff. Okay. Okay. Lastly, I had to do a word problem, and I'm gonna raise this up again. All right. So, Dina has several small clay pots. Their heights are square root of 8 inches, 2 1/3 inches, square root of 5 inches, and 2.5 inches. She wants to display them in order of height from shortest to tallest. So what will be the order of the pots? Flip over my paper. Okay. So the first thing is, again, I want to change things so that they're all decimals. I'm going to start actually with the easier of the 4. I have 2.5. It's already a decimal. So I'll write it down. All right, I got 2.5 inches. Okay. And then I got 2 1/3. So if I take 1/3, that's 2 1/3 inches is equal to 2.3 repeating inches. Okay. Now we have the square roots. So the first thing I'm actually going to look at is, look at the two numbers that are under the square roots. I have an 8 and I have a 5. Well, which one of those is smaller? 5. So square root of 5 has to be smaller than square root of 8. So now we just have to figure out what that is. Now, I look at those two and I think, well, what perfect squares do they fall between? 5 falls between the perfect square of 4 and 9. And so does 8. So that doesn't help me. What does help me is that square root of 5 is going to be closer to 4. So it's going to be closer to the square root of 4, which is 2. And 8, square root of 8 is closer to the square root of 9, which is 3. So they're going to be on opposite ends. So when I take the square root of 5 and I type it in the calculator, square root of 5, boop, 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 I get that it's about 2.2 inches. So that's close to 4, okay? Whereas square root of 8, again, this is why it's good to have a calculator now. Square root of 8 is actually 2.8, about 2.8 inches. So it's closer to 3. So now when we compare from least to greatest, well, we have 2.5. 2.3 repeating is smaller than that, but 2.2, or square root of 5, is the smallest. Square root of 5 inches, followed by the 2 1/3 inches, followed by 2.5 inches, and finally, since square root of 8 is 2.8 inches, that's the tallest pot. I hope this is helpful. I hope that you will be able to now do your work, and I'll see you next time. Bye.